All right, so we're going to finish up our factoring notes. So the back side, we have something called difference of squares. You use difference of squares when there are two terms, and the two terms are only an x squared and a number. You don't have that middle term, like if you look here at number 9, that minus 2x. You don't have that middle term there. Let's see. We also use difference of squares. It has to be subtraction. It has to be, there has to be a subtraction sign between them. There's a difference of squares formula, and here's what the book says. If you have a squared minus b squared, that factors into a plus b and a minus b. So we get this a and this b right here by taking the square root of each of those terms. The square root of x squared is x, so that's going to play the role of your a in your formula. And the square root of 49 is 7. And that's going to play the role of b here in your formula. So x squared minus 49, that factors as x plus 7 and x minus 7. Hey, for the fun of it, these are called conjugates. Conjugates means the parentheses are the exact same, but one has a plus and one has a minus. So this happens because if you FOIL and multiply it, x times x is x squared, x times negative 7 is negative 7x, and then 7 times x is plus 7x, and then 7 times negative 7 is minus 49. So then if you combine like terms right there, negative 7x plus 7x, they zero each other out, and you just get x squared minus 49. So that's why anytime you have a difference of squares, your parentheses are always the same. One gets a plus, one gets a minus, because those middle terms end up zeroing each other out. All right, so this one is also in the form of a difference of squares. I have two terms. In this case, they're both x squared, or they're both a squared, so that's okay as well. There's subtraction. Let's take the square root of it. The square root of 81a squared is going to be 9a. So that entire term is going to play the role of your a when I plug it into the formula. And then I'm going to take the square root of b squared, and I'm going to get 5b. And that's going to play the role of my b when I plug it into the formula. So this factors down as 9a plus 5b, 9a minus 5b. I always put the plus first and I put the minus second, mainly because it's a personal preference. If you wrote 9a minus 5b and 9a plus 5b, that would be okay as well, as long as one's a plus, one's a minus. We have some multi-step factoring. So many times you will have to factor out the GCF and then do more. So the first thing that you always do is look for a GCF. So in number 9, they're all even terms. So they all have a GCF of 2. So that's your first step. Divide everything by 2. So that becomes 6x squared minus 1x minus 1. I still have a trinomial. You have to make an ACB chart, and now you have to factor the trinomial that's in the parentheses. So the second thing we're going to do is your trinomial. All right, so you have to look for your instructions. For a is not 1, and I'm going to do the slide and divide method. So I'm going to move that 6 to the back. I'm going to circle that 6 a couple of times to remind myself to divide by 6 at the end before I finish up. So I'm going to rewrite this as x squared minus 1x minus 6. So when I make my ACB chart, I need factors of -6 that add up to -1. So I know that 2 times 3 is 6, and if it needs to add up to -1, that means the negative is going to have to go on the bigger number. So that factors as x plus 2 and x minus 3. All right, so I'm not done yet because I have to divide both of those numbers by 6. Before you can just simply slide it and put it back, you always have to reduce your fractions. So 2/6 reduces down to 1/3, and 3/6 reduces down to 1/2. Now that 1/2 and 1/3 are fully reduced, and 1 does not go into, I can't divide that evenly, so it looks like both of my denominators are going to slide up. So this becomes 2 times 3x plus 1, 2x minus 1. So that's how that one ended up factoring. Number 10. So I notice that each of my terms has an x in common. So I need to factor out my GCF before I continue on. So then I'm going to follow my steps for a trinomial of a01, and I'm going to do divide and slide. You try that on your own and check my completed notes. So I have subtraction here. I know x squared and y squared are both perfect squares, but 8 and 50 are not perfect squares. So your first step is always take out a GCF. So those are both even numbers, so the first thing I'm going to do is divide by 2. 8x squared divided by 2 is 4x squared. And 50y squared divided by 2 is 25y squared. Oh, that looks much better. 4x squared, that's definitely a perfect square. So when you take the square root of that, you get a 2x. That is going to play the role of your a up in your difference of squares formula. And then the square root of 25y squared is going to be a 5y. That entire term is going to play the role of your b up in your difference of squares formula. So this factors as 2 times 2x plus 5y, 2x minus 5y. Got to have your GCF out in front, because if you multiplied and distributed, the only way that you would end up getting these numbers here is with that extra 8 out in front. And last one. All right, so this one looks like a divide and slide, so I'm going to move that 9 to the back. I get x squared minus 5x minus 90. I'm going to make an ACB chart, and I need factors of negative 90 that add up to negative 5. So sometimes the numbers get a little bigger. Just start dividing in your calculator. I always start at 1 and go from there. So I would have 1 and 90. Let's see, it has to add up to a negative, so that means my negative, or my big number has to be negative. That's negative 89. Moving on. 2 and negative 45. That adds up to negative 43. Nope. 3 and 30. That adds up to negative 27. I did 90 divided by 4 on my calculator, and I got a decimal, so I moved on. 5 and negative 18. That adds up to negative 13. And then I went divide by 6. So 6 and negative 15, that adds up to negative 9. I did 7, nope, decimal. 8, no, decimal. 9 and negative 10, and that adds up to negative 1. So I tried all the combinations that I knew of, and there were no factors that add up to negative 5. Sometimes this happens, so this is just simply not factorable. You could write not factorable, or it's also called prime. I do believe prime is what I'm going to want, but not factorable works as well. So it is prime when you cannot find factors of AC that add up to your B term. And let's go practice some more of these.